Daimler Truck partners with Lindy and completely revolutionizes hydrogen refueling. Will the increases in fueling efficiencies be enough to offset the cost of supercooled liquid hydrogen? I'll go over the announcement and give my thoughts on today's Hydrogen Podcast.
So the big questions in the energy industry today are: how is hydrogen the primary driving force behind the evolution of energy? Where is capital being deployed for hydrogen projects globally? And where are the best investment opportunities for early adopters who recognize the importance of hydrogen? I will address the critical issues and give you the information you need to deploy capital. Those are the questions that will unlock the potential of hydrogen, and this podcast will give you the answers. My name is Paul Rodden, and welcome to the Hydrogen Podcast.
In a press release on February 7th from Daimler Truck, safe, fast, and simple, Daimler Truck and Lindy set new standard for liquid hydrogen refueling technology. Daimler Truck and Lindy Engineering, two leading industry companies, have reached an important infrastructure breakthrough on the path towards decarbonizing transportation with hydrogen. Over the past few years, engineers from both companies have jointly developed the SLH2, a new process for handling subcooled liquid hydrogen. When compared to gaseous hydrogen, this innovative approach allows for a higher storage density, a greater range, faster refueling, lower costs, and superior energy efficiency. Refueling takes around 10 to 15 minutes for a 40-ton heavy-duty truck carrying 80 kilograms of liquid hydrogen for a range of 1,000 kilometers and more. At the same time, the new SLH2 technology lowers the required investment for a hydrogen refueling station by a factor of 2 to 3, and operational costs are 5 to 6 times lower. Today, liquid hydrogen can be supplied reliably throughout Europe. Compared to regular liquid hydrogen, LH2 refueling technology, the new process uses an innovative SLH2 pump to slightly increase the pressure of the liquid hydrogen. With this method, the hydrogen becomes subcooled liquid hydrogen. Hydrogen in this state facilitates a very robust fueling process that also keeps energy losses during refueling to a minimum. Furthermore, no data transmission between the refueling station and the vehicle is necessary, which further reduces the complexity of the solution. At the same time, refueling capacity is increased to new levels. The pilot refueling station has a capacity of 400 kilograms of liquid hydrogen per hour. In comparison to regular liquid or gaseous hydrogen refueling concepts, SLH2 is considered simpler while delivering increased performance. Aiming to establish a common refueling standard for hydrogen-powered trucks, the technology is made openly available to all interested parties via an ISO standard. In the presence of Rhineland-Palatinata's Secretary of State for Economic Affairs, Petra Dick Walter, and international media, Andreas Gorbach, member of the Board of Management of Daimler Truck, and Jürgen Nowicki, CEO of Lindy Engineering, on February 7th inaugurated the first public SLH2 pilot station in Wörth am Rhein, refueling a Mercedes-Benz Gen H2 truck prototype. Andreas Gorbach, member of the Board of Management of Daimler Truck AG, responsible for truck technology, said, "Zero-emission transport needs 3 factors: the right battery electric and hydrogen-powered vehicles, the required infrastructure network, and cost parity for ZEVs compared to diesel trucks. In terms of vehicles, the transformation is in full swing. In terms of hydrogen infrastructure, we are about reaching a major milestone today. With SLH2, hydrogen refueling becomes as convenient as today's refueling with diesel. It takes about 10 to 15 minutes to fuel our Mercedes-Benz Gen H2 truck for a range of more than 1,000 kilometers. We now call on other OEMs and infrastructure companies to follow our approach and jointly make this technology an industry standard." Jürgen Nowicki, Executive Vice President at Lindy PLC and CEO of Lindy Engineering, said, "Subcooled liquid hydrogen considerably increases the efficiency of hydrogen refueling systems. The required investment is reduced by a factor of 2 to 3, and operational costs are 5 to 6 times lower. This and further advantages make SLH2 a practical CO2 neutral alternative to diesel in the heavy-duty vehicle sector. The technology that they've developed, he says, with Daimler Truck will help pave the way for the development of a robust refueling network, which is essential to keeping vehicles moving and supply chains intact. The new public SLH2 refueling station in Wörth am Rhein, Germany, sets a benchmark in terms of energy efficiency and performance, with energy consumption of only 0.05 kilowatt hours per kilogram. It requires approximately 30 times less energy compared with conventional gaseous hydrogen refueling. The refueling station has a small footprint of just 50 square meters, not including the dispenser, and allows for configurations where several dispensers for parallel refueling of trucks are possible, as well as back-to-back refueling. The liquid hydrogen storage tank has a capacity of 4 tons, sufficient for approximately 10 hours of non-stop refueling. Meanwhile, the capacity of the SLH2 fuel station can be increased to over 8 tons per day with refilling. A lower initial investment and operational costs for the SLH2 technology is expected to ultimately result in lower total cost of ownership. Daimler Truck and Lindy Engineering aim to make SLH2 the leading hydrogen refueling technology for heavy-duty trucks. As a result, both companies offer a high level of transparency and openness around the relevant interfaces of the jointly developed SLH2 technology. The technology has been standardized in an open ISO process and is available to all interested parties. Now Daimler Truck and Lindy Engineering call upon other OEMs, infrastructure companies, and associations to apply the new liquid hydrogen standard and thereby establish a global mass market for the process. In contrast to current liquid hydrogen refueling, the SLH2 process is similar to the convenience of current diesel refueling technology. Due to robust insulation and refueling hose and the design of the interfaces between the nozzle and the fuel tank, the process is safe without the possibility of spillage. Therefore, the protective measures required for SLH2 refueling are comparable to those required for diesel. During the refueling process, cryogenic liquid hydrogen at minus 253 degrees Celsius can be filled into 2 connected 40 kilogram tanks mounted on either side of the truck chassis without the need for special safety gear. The SLH2 technology allows for high flow delivery of more than 400 kilograms of hydrogen per hour, and filling 80 kilograms of hydrogen can be completed in 10 to 15 minutes. Finally, the new process avoids what are known as boil-off effects and return gas from the vehicle's tank returning to the filling station, and therefore only one nozzle is needed to fill the tanks, making SLH2 technology easier to handle. The new refueling station in Wörth will be provided with liquid hydrogen by Lindy, which has the largest liquid hydrogen capacity and distribution system in the world. And Daimler Truck prefers liquid hydrogen in the development of hydrogen-based drives. In this aggregate state, the energy carrier has a far higher energy density in relation to volume than gaseous hydrogen. As a result, the tanks of a fuel cell truck using liquid hydrogen are more cost-efficient compared to the carbon tanks used for gaseous hydrogen. And due to the lower pressure, they are also significantly lighter. The technology thus enables a higher payload. At the same time, more hydrogen can be carried, which significantly increases the truck's range. This makes the Mercedes-Benz Gen H2 truck, like conventional diesel trucks, suitable for flexible and demanding long-haul transport. With this demonstrated in September of 2023, when a prototype of the Mercedes-Benz Gen H2 truck approved for public roads completed Daimler Truck's hydrogen record run, covering 1,047 kilometers of distance driven in one fill of 80 kilograms of liquid hydrogen. The company aims to introduce the series version of the fuel cell truck in the second half of this decade. And so from mid-2024 onward, 5 companies are expected to take part in the initial customer trials to first gain experience in the CO2-free long-distance transport with Mercedes-Benz Gen H2 trucks. The semi-trailer tractors will be deployed in different long-haul applications on specific routes within Germany, and they will be refueled at the now open public SLH2 refueling station in Wörth am Rhein and at a refueling station in the Duisburg area. Daimler Truck and its partner companies are thus creating a lighthouse project with the aim to demonstrate that decarbonized transport with hydrogen-powered trucks is already possible today. However, the transformation to succeed, it will be necessary in the coming years to ensure the buildup of an international refueling infrastructure and a sufficient supply of green liquid hydrogen. Okay, so quite a press release from Daimler Truck and Lindy with this gargantuan announcement of not only supercooled hydrogen refueling station technology, but also that they've made this technology completely open source. Now, while no numbers were given specifically, we do get a glimpse of the overall cost reduction in using SLH2 platform and its long-term benefits. I will say that I'm not surprised that this is coming out of Germany. Their push for the hydrogen economy is next level, and it would appear that the traditional German embrace of increasing efficiencies is now getting applied to heavy-duty hydrogen truck refueling. It'll be interesting to see if and how this gets adopted by others across the EU, and along with that, I would bet big that a US adoption of this technology will lag behind considerably, with my only hesitation that Lindy could implement the technology at various locations here in the US with targeted partners, and I would be surprised to hear that they weren't already doing this. The big question I have now is this: with the added cost to supercool the hydrogen, how long will it take to realize the efficiency gains on the downstream benefits this technology represents? Hopefully, we'll get a better understanding of the economics of this value chain soon, as I'm excited about the possibilities this technology offers. All right, that's it for me, everyone. If you have a second, I would really appreciate it if you could leave a good review on whatever platform it is that you listen to. Apple Podcasts, Spotify, Google, YouTube, whatever it is. That would be a tremendous help to the show. And as always, if you ever have any feedback, you're welcome to email me directly at info@thehydrogenpodcast.com. So until next time, keep your eyes up and honor one another.
Hey, this is Paul. I hope you liked this podcast. If you did and want to hear more, I'd appreciate it if you would either subscribe to this channel on YouTube or connect with your favorite platform through my website at www.thehydrogenpodcast.com. Thanks for listening. I very much appreciate it. Have a great day.